Today, I'll show you how Harness AI supports developers across the entire development lifecycle, from writing code in the IDE all the way through to build, deploy, and incident triage, ending with automated verification and safer rollouts. I'm starting here in my IDE, which is connected to Harness via the MCP server. Now, rather than scripting a pipeline by hand, I'm simply going to prompt the agent to create a pipeline for me and trigger it. The agent connected to the Harness MCP server uses tools available to it to create that pipeline, firstly in my repository, then in Harness itself, and triggers the pipeline. Now, once it's done, it also then hands me back the execution URL. Let's go ahead and see our pipeline running. Now we can see our pipeline is running. So now let's drill down into the execution and watch it live. So to recap, from a single prompt, we've gone from our code base to a running CI/CD pipeline. Now there's a failure. Let's not panic. The first thing I will do is simply head back to the IDE and ask the agent to help me diagnose what's gone wrong with my execution. Again, it calls the MCP tools, fetches the logs, analyzes those logs, and surfaces the issue for me. It looks like it's found what the problem is, and that looks like a failed dependency. I'm going to ask the agent to help me fix it. So now it goes to find the offending dependency and make changes to that file. Once that change has been made, I'm going to commit the change, push it upstream to my feature branch, and then raise a pull request to merge that into my main branch. Once I'm done, I'm going to ask the agent to re-trigger my pipeline. So again, the MCP server is called upon. The tools are used to trigger the pipeline again, and now it returns the execution URL. So again, let's jump in and see what that looks like. So now as the pipeline executes, what we expect is that our failed step should succeed. So now it looks like that failed step succeeds. It passes, and now our build succeeds as well. Now with a successful build, we can now deploy the artifact. In this case, we're deploying it directly into our Kubernetes cluster. And so to recap, from a single prompt, we've built and deployed our application. Just from a single prompt. Job done, right? Not quite. It looks like Harness AI SRE is calling me. We've triggered an alert from our EKS cluster. And now when we jump into the alert, we can see that an incident has been created automatically. The AI SRE picks up on key events from Slack, ServiceNow, and our Teams call. And now it looks like our team has already been on the call to discuss what the likely problems are. What it then does is it correlates all of these information sources and gives us probable root causes of what could have gone wrong. From what we can see, its verdict is the last deployment and the last pull request we made are likely the culprits. And drilling in confirms this. The most recent service change in our dev environment triggered this. So now how do we fix this? Well, we simply go back to the IDE, and there are two fixes we need to make. Firstly, we can roll back the service. So again, we simply ask the agent to roll back the service. It uses a combination, in this case, of Kubernetes MCP and Harness MCP tools to find the right deployment and triggers the rollback. We can go into that execution again to see what's happened. And so what we can see now is from an incident that was created, we were simply able to roll that back by using a simple prompt. Now that's reverted us to a known version. How do we prevent this from happening again? Firstly, resilience testing. Harness surfaces AI-driven recommendations for fault experiments to run against our pipeline. I select the pipeline and add a CPU stress test from those recommendations. Done. Typically, this would have taken days, if not weeks, to implement. Secondly, how else can we improve this? We can do this by changing our deployment strategy. We've been doing a simple rolling deployment, so now let's change it. In this case, I'll simply ask the DevOps agent inside Harness to update the pipeline to use a canary deployment with continuous verification. Continuous verification uses machine learning and AI to analyze your APM and log data, automatically detecting anomalies, and trigger a rollback before users are impacted, which would have prevented what we just saw. Once the agent gives me the changes, I can review those changes and then accept that change, and now the pipeline has been updated. So now we have a canary phase with an approval gate and then a full rolling deployment. So to close, from a single prompt in the IDE, we've built, deployed, triaged an incident, rolled back, and hardened our pipeline against future failures.